Welcome back. Today we're going to go over dependent events. Now, like last lesson, this one deals with events, but independent events didn't matter what happened, whereas dependent events, they actually will. So whether the outcome of one event impacts the outcome of another event, it is dependent. Now that's really fancy. What it's saying there is one affects the other. If it affects the other, then it would be called dependent. So reading these scenarios down here, you're going to go ahead and decide whether it's independent or dependent. Go ahead and pause and see if you can answer these before I do, and see if you get them correct. Okay, number one, flipping two coins results in one landing on heads and one landing on tails. Well, no matter how many times I flip those coins, they are not going to affect one another. That's going to be independent. The captain of a football team is selected, and then the co-captain is selected. Now, thinking about this scenario, you have a set of people on this team. If you choose a member of that team to be the captain, they can't be the co-captain if they're the captain. So that one is dependent, because if you take one person out and call them captain, the next person that you call out is going to be co-captain, but they can't be the first person. Okay. You draw a joker from a deck of cards, then you draw an ace. Well, that one is also going to be dependent, because if you draw a joker from the deck of cards, the deck of cards is now decreased by one. You don't have the same amount. If we were to look at that card deck, you have 52 cards in a typical deck. If I take one card out and then I draw again, instead of having a 1 in 52 chance, I now have a 1 in 51 chance, because there's only 51 cards left. You draw a queen from a deck of cards, replace it, then draw a 10. Now that one is going to be independent, and the key word there is replace it. That tells us that the 52 cards is always going to be 52 cards no matter what. So if you have a card, you draw it, you put that card back in the deck, you shuffle it, draw again, you're going to have the same chance of drawing a queen as you will a 10, which makes it independent. Number 5, a coin is flipped and a number cube is rolled. If I flip that coin, it lands on head. That does not mean that it's going to change the outcome of rolling the number cube, because the number cube is going to roll to be whatever number. So that one is also independent. So you'll notice on those two dependent ones, they depend on whatever happens to the first one. Because, like, for instance, if I were to, on number 3 again, if I were to draw an ace, and then I want to know what's the probability of drawing another ace, well, there's only 4 aces. So if I've already drawn one of them, my probability decreases because there's only 3 left. So that one is dependent. But if it said there that I drew an ace and I replaced it, then drew an ace again, that would be independent, because it wouldn't change my actual probability for each attempt. All right, so moving on to this next one, independent probability. We've already did this one in the last lesson. That was the probability of A times the probability of B. So whatever happens the first time, that probability as a fraction, multiplied by whatever happens the second time as a probability as a fraction. Now dependent, it's slightly different. And the only change in here is it's still probability of A and B, but it's the probability of A and then multiplied by the probability of B after A. And that'll make more sense with the little practice that I'm going to show you, but it's basically telling us that our probability changes after you've done the probability of the first. The probability of the second is going to change. So using our understanding of independent and dependent events, answer the questions below. Neil goes to the pet shop, selects a treat for his dog. He chooses one and then chooses another. What is the probability that Neil selects a bone, then a ball? So the probability here, I need to count up the number of items there, which it looks like we have 3 bones, 2 balls, and 2 collars. So that total items there, we have, putting them all together, if you were to choose a bone first, that's going to be 3 out of 7 total choices. But here's the problem. Because this one is dependent, he's not replacing that bone and then choosing again. He has to go through and choose it. Well, there's no longer 7 items. He's picked up a bone. There's only 6 items left. and that means that we have a 2 out of 6 chance to get that. So I have a 3/7 chance, 3 out of 7 items for the first one. For the second one, and that kind of ties into this probability of B after A, there's only 6 items left. Since there's only 6 items left, I then multiply straight across. 3 times 2 is 6, and then 7 times 6 is 42, and then 6 divided by 42 is going to give us 1/7 as a total answer. Now you could reduce this from the start. You could have gone through and taken that 3 and 6 and reduced those, but since we didn't, it's fine. All right, number 7. If you haven't paused it to try it on your own, go ahead and do so now. Mackenzie chooses one candle and then chooses another candle. What is the probability that Mackenzie selects a polka dot candle both times? Now again, this is one that we've done before, but if you notice in the instructions, it says specifically she chooses a candle and then another candle. In the previous assignment, it says she chooses a candle, replaces it, and then chooses another candle. So this one is a dependent event as well. So if she picks a polka dot candle the first time, she has a 2 out of 5 chance of getting a polka dot because there's 2 outcomes, favorable outcomes, and 5 total outcomes. That's going to then be multiplied by the next one, which if she takes a polka dot out, that means there's only 1 polka dot left and only 4 candles left. So we have a 1/4 chance. And then with that one, we times straight across. 2 times 1 is 2, and 5 times 4 is 20. 2/20 reduced down to 1/10. Next question. We're going to read the scenarios here below. For each situation, we're going to determine if it's dependent or independent, and we're going to find the probability of the event occurring. Mrs. Moore is doing laundry and has various pieces of clothing in her laundry basket. What's the probability of selecting a top and then selecting a bottom? So first off, I need to identify how many items are here, and then we got to identify how many of them are tops and how many of them are bottoms. So I'm just going to go ahead and count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 items. So of those 16 items, how many of them are tops? Well, it looks like we only have 1 t-shirt, so we have 1 top. And then how many bottoms? Well, we have 1, 2, 3, 4, 5 bottoms. So if I were to look at this, I'd have a 1/16 probability because there's 1 out of 16, and it says the probability of selecting a top and then selecting a bottom. Notice it didn't say with replacement or replacing it. So that means if I selected something from that pile, the next time I select something from that pile, it's going to be 15 instead of 16 because there's 1 less item. And the bottoms there we already said, so that'd be 5 out of 15. Now, me going through this, I would actually like to reduce it before I move on, just to make my life a little bit easier. And the reason I want to reduce that is 5/15 can reduce. 5 divided by 5 is 1, and 15 divided by 5 is 3. So I'm going to go ahead and just change that to 1/3. Then I can go ahead and multiply. 1 times 1 is 1. 16 times 3 is going to give me 48. So I have a 1 in 48 chance of choosing a top and a bottom randomly from that laundry basket. Number 9. If you haven't paused, go ahead and do so now and then try it on your own. What's the probability of selecting a striped sock, replacing it, then selecting another striped sock? Now again, keyword there, key phrase, replacing it. You've replaced it, so that means that you're putting it back in. So your probability doesn't change. This is independent, not dependent. And so I'm going to go ahead and, since I've determined that it's independent, I have out of 16 chance. The striped socks, we have 1, 2, 3, 4, 5 striped socks. So I have a 5 out of 16 chance of getting a striped sock. And I have another 5 out of 16 chance of getting a striped sock because I put the other one back in the pile. And 5/16 can't reduce, so I'm going to go ahead and go 5 times 5 and get 25, and 16 times 16 to get 256. So you have a 25 out of 256 chance of getting a striped sock, then another striped sock with replacement. Number 10. What is the probability of selecting a towel, replacing it, then selecting another towel? Go ahead and try this one on your own. All right, looking at the information, there's only one towel. So since there's only one towel, I have a 1 out of 16 chance times a 1 out of 16 chance because I'm replacing it back in. If it was without replacement, then that would be 0 because there's a 0 chance of me choosing a towel twice. But it says replacing it, so it's an independent event, and so I have 1/16 times 1/16, and that gives me 1/256. So I have a 1 out of 256 chances of that actually happening. Next question. Mrs. Moore is doing laundry with this one again, and she wants to know the probability of selecting a skirt and a top, one choice after another. Now notice it doesn't say with replacement, so this is a dependent event. So if she chooses a skirt, that's going to be 2 out of 16, and then she chooses a top. Well, there's only one top there, and that's out of 15 choices because she's already got chosen a skirt. Now, if I look at that again, I can reduce the 2/16 and I can reduce that down to 1/8. So I'm going to go ahead and do that. And then I times straight across. 1 times 1 is 1. 8 times 15 is 120. And I have a 1 in 120 chance of getting a skirt, then a top, if I were randomly selecting this. All right, number 12. What is the probability of selecting a matching pair of solid socks, one choice after another? Now, again, it doesn't say replacement, so I know that this one is dependent, which means my probability is going to change after I do the first one. So, solid socks there, we have 4 solid socks. So, I have a 4 in 16th chance, but that means that my next time choosing, I have only 3 socks out of 15 total items. So again, I picked a sock. There's 15 items left. I then pick another sock. Well, I only have 3 choices to get another sock that's a solid. So I can go ahead and take this information, and with this one, I'm actually going to reduce twice because 4/16, both of those can divide by 4, and 3/15, both of those can divide by 3. So I'm going to go ahead and reduce the 4/16 to 4 or 1/4, and I'm going to reduce the 3/15 to 1/5, and then I can multiply straight across. 1 times 1 is 1. 4 times 5 is 20. So I have a 1 in 20 chance of selecting a solid sock, then selecting a solid sock. All right, I hope this was helpful for you in determining what a dependent event is and an independent event. This is one of those things in probability that's a really important step to figure out, but sometimes takes a little bit of effort to learn and a lot of practice. Well, if you have any questions, let me know, and hopefully you guys are staying safe. Have a great day.